Okay, so we talked about in class and actually tried to show the law of conservation of matter or mass. And I use it interchangeably just to remind you. I could say law of conservation of matter, law of conservation of mass, but I'm referring to the same thing. The fact that matter is never created or destroyed, just changes forms. So the amount of matter you have at the beginning has to equal the amount of matter you have at the end, and the things that make up that matter. So if I have certain elements that make up the matter I start with, I have to have the same amount of those elements. They may be in different configurations, but I have the same amount when I'm done. And I'm going to get into that now, how we figure that out. Instead of actually measuring it on a balance like we did in the lab, you can get the formulas, count atoms, and figure out from there. So what do I mean by that? So let me go to that first page, counting atoms. All right, so here's just some terms you need to know when it comes to counting atoms. When you're counting atoms, you need to look at the subscript. The subscript, as we learned before, is the small number that's below, sub like submarine, below, and it is adjacent to the element that it's talking about. So the element right before it or preceding it, the subscript tells you how many you have. So in this case, 2 hydrogen atoms. A coefficient, which is a math term, and it's very similar here, used very similarly here. A coefficient tells you how many molecules of that compound you have, or how many, we'll say compound. You might even have how many atoms of a certain thing, but we'll stick with molecules. In this case, I have hydrochloric acid, and there's a 2 in front. That means I have 2 molecules of hydrochloric acid, 2 of this entire thing. So what if there's both a coefficient and a subscript? Some of you might be very math oriented and have an idea of how to do this already in your head, but I'm going to start by showing you diagrams and explaining it that way and then bringing the math into it. Okay? So the first example I have here, 3H2O, or 3 water. So I have 3 water molecules right here. If I want to know how many hydrogen and oxygen I have, I could just look at my picture right now. You're not always going to have this, but for now we're going to start with this. And if I count the red ones, which are the hydrogens, 1, 2, 3, 4, 5, 6, I have, let me go to my pen, I have 6 hydrogen. Trying to use a stylus and it's not working. Okay. Now, if I get away from this, I look at my oxygens. Oxygens are the purple, and there's 1, 2, 3. I have 3 oxygens. Okay, 3, O. Okay, so in total, I have 6 hydrogen, 3 oxygen, so I have a total of 9 atoms altogether. When I have 3 molecules of water, as it shows right here, 3 molecules of water, I have a total of 9 atoms. 6 of them are hydrogen, 3 are oxygen. Okay, so I'll go through the math part of it. The 3, it's almost like there's parentheses around the H2O. The 3 affects both elements that are here. 3 times 2 gives me 6. 3 times the understood 1 gives me 3. And that's how this is. I showed you the different diagrams and explained the math. So here again I have the diagrams. And just because this is in our way, I'm going to get rid of the writing here. Alright, so now I have 4 carbon dioxide molecules. A lot of purple on this page. 4 carbon dioxide molecules. If I look, I have 4 blue, and that's 4 carbon, so I'd have 4 C. And I have 1, 2, 3, 4, 5, 6, 7, 8, 8 oxygen. 4 carbon plus 8 oxygen means 12 total atoms. Okay? So in 4 carbon dioxide molecules, there are 12 total atoms. So we can count right here. You won't always get the pictures, as I said before, but if you were to look at just this right here, 4 times the understood 1 that's next to the C, since there isn't a subscript, we understand it to be 1. 4 times that 1 means 4, and 4 times 2 means 8. Add those together and you get 12. Okay? So I'll put these back together just to save space and not be so cluttered, because now we're going to go to the diphosphorus pentoxide molecule. There's 3 of them. 1, 2, 3. Okay? Now if I look at it, I have 1, 2, 3, 4, 5, 6 of the yellow. And the yellow is whatever element has a 2 next to it, which would be phosphorus. So there are 6 phosphorus. The purple are oxygen still. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 oxygen and 6 phosphorus. That means I have a total of 21 atoms that are needed to make 3 molecules of diphosphorus pentoxide. And to look at that, to show you the math in that, okay, 3 times 2 is 6, and 3 times 5 is 15. 6 plus 15 is 21, and that's how I got that. Okay, now for this one, I don't have the pictures, so I'm just going to go through the multiplication, or the distribution, and 8 times 6 would be 48, so I can write that down. It's for you guys. Okay, so 8 times 6 gives me 48C. Okay. 8 times 12 gives me 96 hydrogen. And 8 times 6 gives me 48 oxygen. Okay, and then I would add these all together. 48 plus 96 plus 48 comes out to 192 atoms. I'm doing this in my head, guys. If I screw up, I'm sorry. Blame the pregnancy. Okay, 192 atoms total. I'm just double checking a little bit here just so I don't feel like that much of a fool. If I do make a mistake, I am sorry. Okay, so without the pictures, it's still very possible to do this. The 8, the 3, the 4, the 3, they're all coefficients, and they all get distributed to each one of the subscripts. If there's no subscript, it's understood to be a 1. Okay, and then at the end you count up. 192 atoms are needed to make 8 molecules of glucose. All right, so let's go to the next page. The next page, I have a pretty crazy looking one here. All right, I would like you guys to try this one. Actually, no, I'll help you with it. Okay, now the distribution, not so hard for the copper, 3 times 2. So we know that there is 6 copper, okay? That's a lovely looking U, but that is what my U is going to look like right now, okay? Now, what you have to do first is take the stuff, distribute out of the parentheses first to the subscript out here, and then multiply it times the coefficient. Okay, I'll say that again. Distribute out of the parentheses first, then multiply by the coefficient. So, distributing the 1s to the 3 gives me 3 s's to start. Okay, so I have 3 s's up here. I'm just going to put that up here. 3 s's. Okay. And distributing the 4 oxygens to the 3 gives me 12 O's. Now that's just for what's inside the parentheses being distributed to the subscript. Now I have to take these two, multiply them by 3. So in the end I have a total of 9 sulfur. And 12 times 3, 36 oxygen. Okay? So this part, pretty simple. 3 times 2, not so hard. You may want to just go 3 times 3 times s, but that's not what you should do first, okay? It's s times this 3. So however many s's times the subscript outside the parentheses for sulfate. Same with the oxygen, okay? And that tells you how many how many total atoms are right here. And then since there's 3 in this entire molecule, you have to add that in. I know it's probably a bunch of you are freaking out right now for no apparent reason. I know you're just scared, but it's just numbers and it's really not that difficult. So once again, I'm going to say it again. I know for those people that get it, move on. Just fast forward. If you're still a little freaked out by it, this one's pretty easy. There's no parentheses around it, so it's 3 times 2. No big deal. Since there's parentheses around here and there's a number out here, do this part first. 1 times 3, 4 times 3. Do that, then take this number and multiply it times the coefficient. Okay? It really is not that difficult. Okay? So you're going to go now to the worksheet that I posted in assignments called Counting Atoms, and you're going to give it a try. All right, you're going to just label, you're going to identify each atom that's part of the compound and how many of those atoms there are, and then add up and figure out how many total atoms there are for the molecules you're given. So you're going to be working with subscripts and coefficients. I want you to give it a try. If you get stuck, and you just show me which one you get stuck on. But I want you to try each one of them. Okay, there's I think 20, maybe 18, something like that. Or maybe even more. I'm sorry, I don't remember the exact number. I'm not going to pull it up right now. Okay, so give it a try. Come back to the video if you get stuck. If that doesn't help, you ask me in class tomorrow. All right, see you later.